recording. So these are the nonlinear systems, and my highly recommended suggestion is that you use substitution. It's not a guarantee, but it's a suggested tack, because most of these have some type of variable that you can isolate, and then you can substitute it into the other. For instance, this first one, they both have y by itself, and you can look at it two different ways. You can say, I'm going to substitute 3x in for y in that first equation, or you could consider the idea that you just have both equations that are set equal to y. You can therefore set them equal to each other. So if they have them both equal to y, you can set them equal, or think of it as substitution. You decide. So once I do that and I take that 3x, sub it in for y, you have an equation with multiple powers or multiple degrees of a single variable. So we have an x cubed, an x to the first, or any other combination. You don't want to go about solving in any traditional sense. You want to go through the process of setting it equal to 0, then factor it, or if it's a quadratic formula, and then set the factors equal to 0. And this is a common place for people to get mixed up, especially after they haven't seen it for a while. But you want to make sure you don't try and get x by itself in any traditional means. But since we have multiple degrees of x, set it equal to 0, factor, and then set those factors equal to 0. So here's the 0 part. And then once you get there, of course, you combine your like terms. You then take a look at what you can factor out. Now, there's different kinds of factoring. You've seen them all before. This, for instance, greatest common factor, what you can divide out of both terms. In this particular case, we can divide an x out of both x cubed and minus the negative 9x. And when you do, you pull it out front, you have an x squared minus 9 left behind. And if you remember that, that is difference of squares. And difference of squares is a particular factoring method. Two perfect squares being subtracted, you can rewrite it as the square root of the first and the square root of the second term added and subtracted as a product. So these are, and I have that all written out. We did it in class, wrote it on the board as a thing to recall, but make sure you have that fresh, ready to be used in probably 3 or 4 instances here coming up in your practice packet. So GCF took out an x, we got difference of squares, so then we factored from there. That is where we're going to get our solutions, and those factors, which is just, again, multiplied, some type of terms multiplied together. Factors are anything you multiply together to get another result. You want to set each of those factors equal to 0, because imagine anything that you could make the first factor 0. Once you multiply 0 times any of the other factors, you're going to get 0 as a result. So it's called the zero product property. We need to find out what makes x equal to 0, of course. That itself being 0 would be sufficient. We'd be in one of our solutions. The x minus 3 term, if you set that equal to 0, I'm sure you can eyeball it and just say it's 3. But imagine if these got more complicated, just setting the factor equal to 0 is a way to find those solutions, no matter how complicated that particular factor looks. And in this case, so we get 0, we get 3, and negative 3 are all solutions to this. And it's a system, so getting x is one part. But we also, for each of those x's, we need to get a y. Let me back up a little bit. These are, the equations that we're dealing with are something that you should have some familiarity with. Like this is a cubic, the first one. So we have a cubic, and those look like kind of that snaky looking graph. And then the second one is a linear function. It has a slope of 3 and a y-intercept of 0. And if you think of a cubic function and a linear function, they would interact in a potential way such that they would hit 3 times. They'd have 3 intersection points, and that's what we're encountering. We have 3 intersection points. We've got, with x of 0 and x of 3 and x of negative 3 are just the x coordinates of those 3 intersections. Now we got to go about finding the y, and that's a matter of just plugging those x's back into your favorite y equation up above. You decide. So I like the y equals 3x, so if I want to get y for this next one, I just got to triple my x. So the first one's 0. Then this next one, if x equals 3, which I didn't write, here we go, then my y is triple that, which is 9. And then the last one, if x is negative 3, then you triple that and you get your y of negative 9. Those are our 3 intersection points of 0, 0, excuse me. Then negative 3, negative 9, maybe I can even label them in this picture, negative 3, negative 9. We got 0, 0. And then we've got 3, 9, and those are our solutions, the intersections of the graph. The next has another somewhat familiar graph. Maybe you've seen this before. This is a circle with a radius of 10. We'll talk more about that in the next unit. That's our conic section. This is a linear equation. And imagine a circle and a line can interact in, they don't intersect. They can intersect in a tangent sense where the line just touches the circle once and it's tangent to it, or it can intersect it twice by passing through the middle. We call that a secant. To solve this one, again, you're going to go substitution. So if you get y alone, I'd suggest the bottom equation. You get y equals 2 plus x, and then you can take that expression and sub it in for y in the above circle. And it gets us into a territory that's pretty common, where error is kind of, if I were to talk about one error that's most common in pre-calc and even beyond and even in calculus, it's this one where you put a binomial and you square it, and how to write that out. So let's put it in its place, x squared plus, and I'm going to replace that y with 2 plus x and square it and set it equal to 100. And what I'd say most math teachers, even those that are in college, will talk about is the distribution of a power over a plus sign is the big error. This is in no way 4 plus x squared. So on the board, we wrote this in class. This is 2 plus x times 2 plus x. To square a binomial means you multiply by itself. So make sure you always think of squaring as something times itself. So I'm going to take that and put it on the next page. Let me grab this here for a second and lasso it up. Next page. Put this there some room. There we go. And I get x squared plus x plus 2, or 2 plus x